You have used it before, maybe even today. You typed something in, got a fluent, confident answer, and moved on. But did you ever think about what actually happened there? How did the system go from your question to that answer? Because inside that system, in that fraction of a second, something very different is going on. It does not think the way we think. It does not plan the full answer in advance. It does not even know what it's going to say next. And yet, it still works. So in this video, we will break down what happens after you type a question and before the answer appears. Let's say you ask, plan a cheap 5-day trip to Tokyo. Before the model can answer your question, it first has to read it. Now when you read a sentence, you understand it almost instantly. You don't think about individual words. You just get the meaning. The model cannot do that. The very first thing it does is break your sentence into smaller pieces. Every word, every piece of punctuation split into smaller chunks called tokens. Tokyo might stay whole, 5-day trip might become 5 hyphen or day. So what used to be a sentence is now just a sequence of pieces. Then each of those pieces is turned into a number, a position in a mathematical space. Words used in similar ways end up close together. For example, Tokyo and Paris are nearby, but carrot somewhere far away. So now the model has a representation of each word. But that's still not enough, because meaning does not come from individual words. It comes from how they are used together. For example, consider these two sentences. Plan a cheap 5-day trip to Tokyo, and what is the history of Tokyo? Same word, Tokyo, but in one case, it's about travel, in the other, it's about information. So the model has to figure out which words in the sentence are actually important for the current meaning. You can think of it like a spotlight. Some words are bright, they carry the meaning of the sentence right now. Others are dim. They are still there, but they don't matter much. In the travel sentence, cheap, trip and Tokyo are bright. Words like to or a fade into the background. This system is called attention. Now the next question is, how does the model decide which words are bright and which are dim? For every word, the model looks at all the other words in the sentence and asks a simple question. Which of these words actually matter right now? Take the word trip. The model checks, is Tokyo important here? Yes. Is cheap important? Again yes, but to? Not really. Based on that, it assigns more importance to some words and less to others. So words like Tokyo and cheap have a strong influence on trip, while words like to barely matter. This is what attention is doing. It is deciding for each word where the model should focus and where it should not. Now when all those decisions come together, the model ends up with a clear sense of the sentence. Not only the individual words, but the actual context of the sentence. And that understanding is what it uses to predict the next word. So when the model starts generating a response, it already knows this is about a trip in Tokyo with some constraint like cost or duration, and in that context, a phrase like a 5-day plan becomes very likely. It did not memorize your sentence. The meaning of your question points strongly in that direction. And this entire process, breaking into tokens, comparing words, assigning weights, happens for every single word. Every time the model generates a response. So at this point, the model has done a lot of work. It has broken your sentence into pieces. It has figured out which words matter most. It has built a focused understanding of your question. But the strange part is, it still doesn't know what it's going to say next. The model never starts with a full response. It builds it, one word at a time. At each step, it looks at everything it has so far, your question, and every word it has already generated, and tries to figure out what is the most likely next word. Behind the scene, it assigns a probability to every possible word it knows. Not just a few options, tens of thousands. Each one gets a score. And from that entire list, it picks one. That word gets added to the sentence. Now the sentence is slightly longer, The context has changed, so the model repeats the same process again. Look at everything so far, predict the next word, add it, and this process continues. This loop runs hundreds of times to produce a single answer, which is why responses often appear on your screen one word at a time, like someone is typing. Now there is a fundamental problem. The model is not checking whether what it just said is true. It is predicting the most likely next word, not necessarily the most accurate one. And that difference matters more than it seems. In 2023, a lawyer in New York submitted a court brief citing 6 legal cases. The document looked professional, well written, confident. There was just one problem. None of those cases existed. Names, dates, legal reasoning, all of it sounded completely real, but it was not. They were generated by AI. This kind of failure has a name, hallucination. And to understand why it happens, you have to go back to what the model is actually doing. At every step, it's choosing the next word based on what is most likely to come next, not what is verified. And most of the time, that works. Because language has structure, words tend to follow certain patterns. However, when it doesn't know something, instead of saying I don't know, it produces an answer that looks right, sounds right, but actually wrong. That's what makes this failure different. It's not random, it's structured and convincing, and that's why it's dangerous. Now modern systems have improved a lot. They can use tools, search the web, retrieve real information, check the sources. But underneath all of that, the core behavior is still the same. Predict the next word. Which means this problem has not disappeared. It's only been reduced. The people who get the most out of AI are not the ones who trust it the most. They are the ones who know when to pause and double check. And we all should do that.